outside. It is cold again today. Because our mechanic has a problem. He's trying to sell his house. He almost had a deal, but last moment he realized that he would be let's say defrauded. But he has to help his son, because his son, comes to him, tells him he has a problem, blames him for all the problems, and stuff like that, typical stuff. But he says, I'm like $1,000 in a debt, so he borrows $1,000. Week later, well, I didn't want to tell you, but I had a bet on something, so I hoped I would clear it up, but now it's 15,000. Yeah, so it's it's like that. And I am not going to claim he's like a perfect father or never did. First of all, they are after divorce, so you can imagine that you have parents who play child against each other and stuff like this. So yeah, I'm not going to claim that my friend, the mechanic, is perfect, but he isn't like I don't know, someone who abandons their kid or someone who treats them horribly. Normal, less than perfect father in less than perfect home. So stuff happens. Okay, I will be back in a moment. I will pause here and be back. Okay, I'm back. Yeah, and yesterday I recorded this slow motion video, but because there was a car coming from the other way around, it took me like 2.5 minutes to get to home, which made the slow motion video over 10 minutes long, which didn't exactly make sense to post a footage of me speaking super slowly, and this thing. Just so that you could see some cool stuff. 240 FPS. There is an option, it can record up to 960 frames per second, but only for 3 seconds, I believe. 240 can constantly, but only in full HD. Bandwidth wise makes less sense, but it's probably not bandwidth constraint, but something else. I do wonder if full Snapdragon 8 Gen 3 instead of 8S version that I have. Has the ability to record 240 in 4K. Difficult, or at least not constantly switching to 30 FPS in 4K. I used to learn about, I used to know a fair bit about optoelectronics. It doesn't look like a bandwidth problem. Or at least not in and out bandwidth problem. Maybe sensor bandwidth problem, maybe, but not necessarily in and out. I doubt that. And also can be artificial segmentation. Someone remembers what happened to Xeon bronzes when you activated AVX-512. You know, which were those Skylakes, Oswell, Broadwell, stuff like this before Skylake, probably even Skylake X. I don't remember, but the exact generation, but Jesus, 800 megahertz. And that was artificial. That wasn't because it couldn't do it. It could. They even sold for money as a DLC that you could upgrade your CPU already installed. It could run faster. Okay, I'll be back in a moment. Okay. And to the point that Intel did that with CPUs, to the point that people started to think that AVX-512 was bad, or slow, or hot or something. Hot, yes, and use a lot of power, yes, sometimes, but it was still more efficient. Often even if with artificial segmentation. Probably except those bronzes that run at 800 megahertz. Although at 800 megahertz they use not much power. The problem was that algorithmically AVX-512, that's a 512-bit SIMD data path, right? Just like MMX, like SIMD, SSC original, so first there were 64 bits and 128 bits. The thing is that you can pack instructions usually of length 32 or 64 bits into a vector 512 long, and you can execute single instruction on multiple data sets, multiple data paths, multiple, there are many translations. Oh Jesus Christ, the prices of oil are like after Ukraine was invaded. I mean, in a week it's jumped like 40 cents for a liter, so like $1.50 a gallon, something like that. Yeah. Okay. Let me continue my rant. Okay. So yeah. AVX-512 again. We are talking about 512-bit long data path, right? And you can execute all those 32 or 64-bit instructions at this. Well, that's one instruction on multiple data. So you pack, in case of 64-bit instructions, there are 8 of them in 512 bits, right? Okay. Zobaczyć tak. Proszę bardzo. Okay, no. And the way you do it is that basically this is a SIMD, so single instruction multiple data. So you just take these 8 data points and you execute a single instruction on them. So for example, you might XOR all of them or do some kind of operation. The thing is that you are getting a lot of performance because you are doing effectively 8 times the work, or in case of 32-bit numbers, 16 times the work. Now that's stuff like this. Of course, all of those need to have to be made to have the same operation. They need the same operation. So sometimes, in order to prepare them, you need to, for example, go through 2 or 3 different operations to get a result that can be executed at 8 times faster. But because you are executing 8 or 16 times faster, then even if it takes 3 of such instructions, then it only took less than half of the time, right? So you had more than 2 times gain. So what Intel did? Well, Intel did the genius thing. That wasn't actually that bad. That was sort of smart. They enabled only 128-bit data path for the first 50,000 cycles. 50,000 cycles in CPU time it's a lot. Probably enough so that, but it's not enough. I'm wondering whether it's enough to that voltage regulator, because that was supposed to be so that, because it was much heavier workload, when you use electronics more heavily, you get a bigger voltage droop. So voltage regulator needed more juice. So it preemptively, for 50,000 cycles, it lowered, instead of 512-bit path, you had 128-bit path. So 1/4. So at best you were doing a 2 times speed up, and during that time you also had an increase in decrease in CPU speed in clocks. So yeah, that was fantastic. So you had, 4 times lower effective clock rate, and often, half of the clocks. So your 8 times speed up became 8 times slower, or rather no uplift at all, but because often you had to replace more than one, you had to use more than one instruction to replace one older instruction, you often ended up with a slowdown. That very heavily depended on the instruction, because AVX-512 also includes 128-bit and 256-bit instructions. Not all of them are 512-bit. So yeah. Okay. Jesus, I'm giving a lecture on electronics during groceries. It's weird. Okay, I see a lot of promotions, so I might be here for a while. You know what? See you later. Okay, what was I on about? Ah, yeah. When AVX-512 is implemented properly, so basically Zen 4, Zen 5, early Alder Lake, or 11th Gen, generally speaking, has okay implementation. When it's well implemented, like in Zen 4 or Zen 5, it's fine. I mean, I remember how I had a laugh when I read Alexander Z article on Zen 5 teardown, AVX-512 teardown, and how AMD implemented VP2 intersectors that are similarly named function that Intel badly implemented once in their CPUs. It was incredibly bad implementation that took like something like 20 something cycles. People found other way to do it faster using different instructions, and the workaround was like 18 cycles or something like that. And here comes AMD that was in 2024, and they implement full AVX-512 for the first time formally, because Zen4 had double pumped officially AVX-512. And what AMD has? AMD has this useless function called VP2 intersect that executes in one cycle. I don't know if that just did it for the flex, or like, yeah, we can do, when competent people start to make CPUs, yeah. Alexander E, by the way, Alexei, also known as Mystical, I believe, on Stack Overflow. Kind of legendary person there, especially in C++. Also known as the creator of Y-Cruncher, so one of the few applications that is basically optimized for every architecture. So that's why he is a specialist on the topic. Like, he is, apart from people in AMD and Intel, he is the specialist on x86, as close as you can get, basically, being civilian, being non-affiliated. Okay, thanks, subscribe, like, we'll do whatever. Okay, bye.